Hey friends, Mrs. Derby here. I thought I would do a couple examples of how we did some graphing, sketching polynomials here in Unit 2, Lesson 10. So just picked a couple of them here at random and we'll see kind of what the differences look like. We're actually going to do D and then bop down to F right below it. So a couple things as we go through this. I do it in a certain order. There's no necessarily perfect order to do this in. But some things that we are going to definitely need to know as we go through our graphing. We will need to know how to turn factors into zeros. We will need to know how to find the leading term. That'll help us know the end behavior. We would need to know how to find the constant. That's going to be our y-intercept. And we would also need to look at things like multiplicities and understand how different multiplicities are going to show up in some different ways. So I'm going to kind of work in these 4 steps because it's nice to have at least something that'll get us going. So I see that we have 2 factors in example D. One of our factors is x plus 6. And to turn that into a 0, remember we're going to set that equal to 0 because that's what we're looking at. When the output of the graph is 0, it'll be right on the x-axis. To get x now by itself, I would need to subtract 6 from both sides. So one of our zeros happens when x is at -6. One of our other zeros, in fact, we only have one other factor going on here, at x plus 2. So when that factor is set equal to 0 and we solve for x, we find that x equals a -2. So we have turned both of our factors into zeros in that way. Now I need to find the leading term to get this end behavior thing going on. Right? Now when I think about the leading term, I can certainly multiply all of this out so that it's in standard form. But I'm just going to kind of do the shortcut way to go about it. Now I did 2x plus 6's because this degree of 2 here, this exponent, is telling me this factor happens twice. So when I just look at all the things that are multiplying that would lead to my leading term, I have a negative out in front, an x, an x, and an x. If I had a coefficient out in front, I'd also have that number, and if any of these x's had a coefficient in front of them, I would still use that number too. But what I really have is just a negative x, 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 which we might know as negative x to the third. That's telling me a couple things. First of all, it's telling me it has a degree of 3. But this is also helping me know my end behavior. Remember, a leading coefficient in front tells us what's happening at the right side of the graph. So this graph, because it's a negative leading coefficient, is going towards the negatives. It's going down, 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 down on the right side. Did I say left before? I hope I said on the right side, because the right side of the graph is going down, down, down forever. So the leading coefficient, what's happening in front, tells me what's happening on the right side of the graph. The degree, whether it's odd or an even number, tells me what's happening on the left side of the graph. In this case, it's an odd number, so the left side of the graph is going in the opposite direction as the right side. So my left side is going up forever. If you need to skip back to that look at lessons 8 and 9, where we were talking about end behavior, you would see this idea. Negative leading coefficient, odd degree, has up, down, end behavior. So as x gets larger and larger in the negative direction, meaning as x goes negative, our graph is heading upwards. We worked with our leading term. Now we want to think about the constant of what's going to be happening. Now it might be helpful to actually multiply this whole thing out into standard form. it's going to help us find the constant. But again, I can also still use kind of my shortcut cheater's way of doing it. And just like we took all of our x terms to find our leading term, I'm going to also do that same kind of multiplication to find my constant. Now I make sure that there's 1 in every single term first. So we'll see what that looks like down below when there isn't a number in every single term. So to find my constant, I have a negative times a positive 6 times another positive 6 times a positive 2. And when I multiply all of these things together, I have, let's see, negative 6 times 6 is 36, times 2 is 72. So I have a negative 72. That y-intercept is going to be way down here at a negative 72. Now the last thing I'm going to look at is the multiplicities. And remember that a multiplicity shows up like a exponent on a factor. Okay, so it's outside of a factor. What's going on here? This factor, this tells me that this negative 6 factor turned into a 0, this one right here, has a multiplicity of 2 because it has a 2 in the exponent. So this guy has a multiplicity of 2. And if we have a multiplicity of 2, it's going to have the shape like a parabola, right? Something x to the second power. So we're going to have it either shaped like that, bouncing on the axis, or it may come from the bottom and bounce up. So it's just going to touch 6 and then bounce back down. I don't know which one it is quite yet, but I like to put a little reminder of both of those, so it's one or the other. I don't know which. Now my 0 here at negative 2, it doesn't have a degree to it, so this one's going to just go straight through. No bouncing, no stutter or anything like that. So from here, I'm really just going to connect the dots of what I see that's going on. I have this upward end behavior on the left, so it's going to come down, and it looks like it's just going to bounce right off the x-axis here at negative 6. Now I don't know how high it's going to go, but it's going to have to take this kind of U-turn to go straight through negative 2, go down to negative 72, and then keep on heading downward from there. So I've got my up, down, and behavior. I've hit my 2 zeros. 1 0 had a multiplicity, so I've got a bounce going on there. And it goes through negative 72 on the y-axis. I've got a really solid graph going on here. Let's just take a look also at example F, because some different stuff happens here. I notice it's got some different degrees. I notice it also has a factor without any plus or minus in it, so it's just x by itself. So when I think of the degree, I'm going to first start with my factors and zeros. I'm going to go in the same order that I did before. So each factor turns into a 0. Well, this one is just right at 0. This factor into a 0 would turn into a negative 4. Remember, it's just, unless you have a coefficient in front, you just flip the sign there. This one would turn from a x minus 3, would have a 0 at positive 3. So I have zeros at 0, negative 4, and positive 3. At 0, negative 4, positive 3. I now have them on my graph. Now this factor, I want to skip ahead a little bit to that y-intercept. It is on the y-axis. If it's right here at the origin, 0, 0, that is my y-intercept. That's it right there. So even if I did multiply all of these out, which I guess I could do, like putting it into standard form, really what I have is an x plus 0 to the third power. So I'm just rewriting this x to the third, thinking about what that constant would be if it had one in there. And then now we'll see a little bit more about what's going on. Because now when I take all of my x terms and multiply them together, I have x to the third times x times x times x. What I have is a degree of, let's see, there's a degree of 3 right there, plus another 1, 4, plus another 1, 5, plus another 1, 6. This thing has a degree of 6. And the leading term would just be x to the 6th power, because these are all positive x's that we have going on here. So a positive leading term, positive leading coefficient, ends upward on the right. Even number has the same end behavior on the left. So we have up, up end behavior. So we've turned our factors into zeros. We now have our leading term, a positive x to the 6th, which told us the end behavior. The constant, I already know, is here at 0, because when I would multiply the constants all together, I'd have 0 times 4 times negative 3 times negative 3. Anything times 0 is 0. So there is my y-intercept. And the last thing I need to think about are the multiplicities. Okay? This one here has a multiplicity of 3. Our 0 at negative 4 just has a multiplicity of 1. It just happens one time. So it's going to go straight through that graph, because it only happens once. Our 0 at positive 3 has a multiplicity of 2. And we saw in our example up above that a multiplicity of 2 means it's going to have a bounce. It's either going to bounce up or it's going to bounce down. I don't know which direction it's going to come from. So this multiplicity of 3 we haven't seen, or we haven't looked at an example yet for it. A multiplicity of 3 is going to look like a cubic function, and a cubic function would look like that, or maybe like that. It has this kind of place where it plateaus or levels out or hits like this pause right at the 0. And so it's going to come up and it's going to kind of pause for a little bit here where this multiplicity of 3 happens. So I don't know if it's going to come up from the bottom, pause, and then keep on going, or if it's going to come from the top and pause and then keep going downward. But I know there's a multiplicity of 3, and that kind of shows up like this little plateau thing, a little pause where it just kind of goes horizontal for just a bit and then starts going down. Now it's important to know that these multiplicities, the same things happen for every even multiplicity. We'll have a bounce. And same thing with every multiplicity of an odd number, we'll have a pause like this. And the bigger the number, the longer that pause or that bounce happens. All right. We'll take a look at some examples of those later on, I'm sure. But for now, we just have a multiplicity of 3, a multiplicity of 2, and one that goes straight through. So let's start connecting these ideas together. My upward end behavior would have to go directly through that negative 4. Somewhere down here, it's going to take a U-turn, and it's going to start heading up to the origin, and here's where it's going to hit that little pause, that multiplicity of 3. I don't know how high up it goes, but somewhere it also has to take another U-turn, because it's got to, remember, come back down to the 3 and bounce off the 3. And then it's going to continue upward to end heading upward with our up end behavior. So we have a graph where we found it had up end behavior, went through a 0 at negative 4, 3 zeros right on top of each other at 0. two zeros right on top of each other at positive 3. So it goes straight through negative 4, a little stutter or a pause right there at the origin, comes up, bounces down at negative 3, and then continues upward forever and ever. Some great examples, and remember you can always look at a Desmos and type this in just to see exactly what it looks like, and to make sure you've got this right before you would turn any assignments in. Thanks guys, appreciate you watching.